Shall I start? Okay, good afternoon, everybody. Thanks for coming. So today I'm going to give a talk on a use case for Bitcoin. So we know Bitcoin is the most valuable asset in the crypto system, but we can also view it as a public good to be used for other blockchains. So that's what the talk is about. So let's talk a little bit about the history of the blockchain space. So we start with Bitcoin. That's the first blockchain. What's so good about blockchain? About Bitcoin? Well, one thing good about it is it's really secure. It has never been attacked before. Very good track record. Now, is there another blockchain which is equally secure as Bitcoin? What do you think? Well, we're at East Denver, so I guess there is one. There's Ethereum, also a very secure blockchain. Now, there's one difference between Bitcoin and Ethereum, though, is that there has a lot of work on scaling Ethereum. Huge amount of work, research, engineering work. In particular, we know that there are these roll-ups which allow us to scale Ethereum to high throughput, and a lot of research, a lot of cryptography has been gone into developing technology to make these roll-up not only scalable, but inherit the full security of Ethereum. So a lot of this engineering and research is about how to share the security of Ethereum while being with these roll-ups. The recent development with Coinbase issuing a new roll-up base adds another dimension to this feature set of Ethereum, the goal being interoperability. So now you have a lot of roll-ups scaling, but now they have to talk to each other. And that's what Superchain is targeted for. All right, so now what we're seeing here is a lot of activities in the Ethereum ecosystem, building towards a system with security, scalability, and interoperability. Okay, good. So here's a thought. Is there a different way of building such a system? In fact, there is an ecosystem out there which has some of these features already in operation. And this is the Cosmos ecosystem. So we know that Ethereum went through the merge a few months ago, but actually Cosmos ecosystem is one of the early ecosystems with proof-of-stake protocols. It started about 3 or 4 years ago. So in this ecosystem, it is called an inter-chain ecosystem. It's also called app chains, application-specific chains. By the way, can people actually hear me? It would be a bit disaster to talk for 20 minutes and nobody can hear you. Okay. This is one of the noisiest places I've ever given a talk before in my life, okay? So if I could give a talk here and capture attention a little bit, I think I made it. Okay. All right. So Cosmos have all these app chains, and therefore there's built-in scalability because all these app chains are running in parallel to each other, focusing on their own application. They're also interoperable because there's a very important technology in Cosmos called IBC. How many people have heard of IBC? Oh, good. inter-blockchain communication. It's like the internet, TCP/IP for the internet, okay? It's the analogy. So you already have a system with these two features. Not only that, but each blockchain, it has its own sovereignty, so their own governance, their own community. What is missing in this ecosystem, however, is security. Because these chains are smaller, the market cap is smaller, the security is lower, okay? So a year ago, we made this observation that there is this very exciting ecosystem with a lot of these features already, but what is missing is security. And so we are building a project, we built a project which marries Bitcoin to this ecosystem, using Bitcoin as a public good for security, okay? So you can think of, there are quite a few projects that tries to build on Bitcoin to make it more interesting, more useful, yes? Our approach is actually to take an existing flourishing ecosystem already and try to borrow the security from Bitcoin to enhance the security of this ecosystem. So that's the difference between our approach. Okay, to take an existing ecosystem and add Bitcoin security on top of it. Okay? It's a bit weird. You know, when you design protocols, you usually start with security. But now we have all the other feature sets, but we don't have security, and now I'm adding security on top of it. Okay. All right. So you may ask, so why do we take Bitcoin to do security sharing? Well, there are two pretty good reasons. One is that it is a proof of work chain. So being a proof of work chain, it is different security model than proof of stake, which suggests that combining proof of work and proof of stake can give you a richer system because of diversity and complementary benefits of this protocol. So I'll give an example of that. Second, it is 400 plus billion asset. So if you think about economic security, it's incomparable. Okay, there's no chain with such a high asset. As I mentioned, 14 years of track record of security. So I think these two reasons are pretty good to think of Bitcoin as a source of security for securing app chains. Okay? All right. Our project actually started with the first one, proof of work combined proof of stake. So I will show you a little video explaining why a proof of work chain like Bitcoin can actually improve the security of proof of stake chains. Okay? Then I'll go back to what we're building to extract the security. Good? All right. Now you don't have to listen to me anymore.
In a blockchain, blocks are validated through primarily one of two mechanisms, proof of work or proof of stake. Each has strengths and weaknesses. For example, a proof of work chain like Bitcoin is extremely secure, but it also consumes lots of energy and has a slow confirmation rate. Proof of stake is faster and more energy efficient due to the fact its validators stake tokens instead. On the surface, this appears to make proof of stake a more attractive option, but it's not quite so simple. Because of the lack of work to support its security, proof of stake chains have many more attack vectors than proof of work chains. Through intensive research, the design of proof of stake protocols has been improved to repel many of these attack vectors. But one attack vector remains: stake reuse attack. All proof of stake chains suffer from this attack. This is where an attacker can reuse its stake to build an attack chain after unstaking on the correct chain. The solution to this is called social consensus, where the community of users agree on the correct chain before unstaking is allowed. However, this is far from rigorous and very slow, meaning validators who want to unstake tokens can wait a long time, typically 21 days for a Cosmos zone. Suddenly, proof of stake doesn't feel quite as fast or efficient. An alternative to social consensus is the use of an external secure blockchain to timestamp proof-of-stake blocks. This way, the correct chain is established as rigorously as the chain with the earlier timestamps. For example, a secure blockchain like Bitcoin can confirm a timestamp in a matter of hours, meaning unstaking can happen much faster. Unfortunately, Bitcoin's low throughput is a major barrier to this happening for many proof-of-stake chains, and mass adoption of this technique would undoubtedly cause major scalability issues. But what if we could remove this barrier and make the best of both worlds to create a better blockchain? Babylon, a timestamp aggregation service which bridges the security of Bitcoin to multiple proof-of-stake consumer chains at the same time. Designed to transform the way proof-of-stake chains communicate with Bitcoin. Babylon works by aggregating the timestamps of multiple proof-of-stake consumer chains and then uniquely submitting them as one to Bitcoin. The size of these Bitcoin stamps is also minimized through cryptographic techniques, meaning the footprint of Babylon on the Bitcoin network is extremely small and does not scale with the number of consumer chains. The outcome? A brand new solution that combines the energy efficiency and speed of proof of stake with the enhanced security of proof of work. Babylon, the future of proof of stake.
How is that voice? Better, right, than my voice? So I had a choice of British or American accent. I think I chose the right one. All right. So, yeah. So that's the starting point of our project. The last year, we've been building this technology, and we've just launched our testnet. Okay? So I was going to do a live demo here, but given the environment, I decided not to do that. So if you're interested, please go to our website, and you can check out our explorer of the testnet. So I'll show a screenshot to walk you through a little bit what's going on here. All right, so as the video said, Babylon is using this technology called timestamping, okay? So in Nakamoto's white paper, he mentioned the following fact, he or she or they mentioned the following fact, that the Bitcoin chain is a timestamping server. It timestamps Bitcoin transactions to make sure that everything is in the right order. What we're doing is we're using the same idea, but to timestamp proof-of-stake blocks, like Cosmos chain blocks. And what this technology is doing is we're building a Cosmos chain called Babylon, we have built one, which timestamps onto Bitcoin, and it allows many Cosmos chains to timestamp onto Babylon, and using the timestamp from Babylon, you get a single timestamp, so that not every chain has to timestamp to Bitcoin directly. Bitcoin is very fuzzy about sort of putting a lot of stuff on the Bitcoin chain. Okay? All right. So right now on the testnet, we have 8 Cosmos chains. These are all application-specific chains, all timestamping onto Babylon. Now you may think, whoa, this timestamping is really complicated. If I want to timestamp, if I want to go to Babylon to get Bitcoin timestamped, do I need to do a lot of stuff? No. If you are a Cosmos chain, then you can simply open an IBC connection, inter-blockchain communication connection, to Babylon. And once you do that, actually IBC automatically, for some magical reason that we discovered, do the timestamping for you. And so therefore, what we're doing now is we are getting a timestamp of every block of every one of these chains. So every chain has a Bitcoin timestamp saying, hey, this block was created at this time according to the Bitcoin chain. And so, for example, if you want to do unbonding, then you can say, okay, I've sent an unbonding request in a block, timestamp onto Bitcoin chain. When it's 100 block deep, for example, very, very deep, then it's very secure. The unbonding request cannot be reverted, and then you can safely unbond. And that takes about 16 hours. 100 block deep is about 16 hours. So these are the current numbers here, 16.39 unbonding hours. This is compared to 21 days on the typical Cosmos chains and compared to infinity on Ethereum. Infinity. Right now, there's no unbonding yet. When there's unbonding, it will be slow. All right. So this is how the timestamping works. So now, in addition to unbonding, fast unbonding, which is every chain likes that. Nobody wants to wait 21 days when they can unbond in 16 hours. More generally, you can think of this Bitcoin timestamping as giving you additional security in addition to your native proof of stake chain. How does this work? All right, so on the left is one of our partner chain, Osmosis. It is timestamping to Babylon in the middle and timestamping to Bitcoin so that every block gets a Bitcoin timestamp, okay? So this is a Bitcoin timestamp, 1, 2, 3 here. So in a Osmosis chain, you first get Osmosis confirmation, okay? So this is, the confirmation is economic security of Osmosis validators, about 400 million. Osmosis validators, the stake is about 400 million, okay? Compared to Ethereum, it's not much, 400 million. Okay, so you say, hey, this is okay for normal transaction, but suppose I have a very important high-value transaction. Maybe I should wait until the Bitcoin miners weigh in to make sure that this is confirmed. So I wait until I get BTC1 confirmation. That means one block has built on the timestamp. I say, okay, that's not quite enough. Let's wait a little bit longer until I get BTC2 confirmation. Now, Coinbase would confirm a Bitcoin transaction when it's 2 confirmed, 2 block deep. So this is Coinbase level confirmation. So this is very secure. So this is a way to get economic security from Bitcoin. And now if a wallet, when we're talking to wallet, if you integrate with wallet, our service, then in addition to telling you that a transaction is successfully confirmed on the Osmosis chain, it will also tell you that it has BTC confirmation 0, 1, 2, so that you look at your wallet, you say, hey, good, my 1 million Osmo token transaction is now confirmed. I'm sure it's got into the chain, no problem. Okay? All right. So you can do the same thing for IBC relay. So if you want to transfer funds from one chain to another chain, you can also put these Bitcoin confirmation into the wallet. Okay. So going back to the question of reducing the native economic cost. So basically, you can think of there are many attack vectors out there. Long-range attack, I mentioned, which is the unbonding attack. Double spend attack, which is the forking. Invalid execution, you create money from nothing. Or liveness attack, which is store the chain or you do censorship. Okay? So all these attacks, let's see how Bitcoin security can protect you. Which kinds of attack can protect you? It can protect long-range attack, I already showed earlier. It can also protect double spend attack because whenever there's a forking event, the timestamp will save you. However, invalid execution, Bitcoin cannot help you because when you create money, Bitcoin miners don't know what you're doing. They don't execute your transaction. Here, however, with new technologies like zero knowledge or fraud proofs, this can solve this problem. So this is a short-term problem, not a long-term problem. So therefore, actually, with Bitcoin security, all is left is your concern that your chain should remain live And so basically that's roughly the cost of running the validators to keep the chain moving, okay? So last year, Osmosis security cost in terms of staking reward is 50 million. The cost which goes to the validators of running network is about 2.5 million. So you can see that with Bitcoin security, there's a pretty big range. You can reduce the security cost, and that would allow the inflation of the coin to lower. So this is very healthy for the tokenomics of the chain. Okay, that's it. So that's our project, and we have a team of, this is our team of engineers and researchers all around the world. And if you want to find out more about the project, you can go to our website or follow us on Twitter. Okay, thank you. Do you have time for 1 or 2 questions, maybe? Yeah. So the concern is that so the question is, what happens if your timestamp get reorged out, because in Nakamoto consensus, blocks can get reorged out, yeah? So the way to prevent it or minimize the chance of that is to make sure that your timestamp is deep enough in the Bitcoin chain. So for example, for the unstaking, we wait until it's 100 block deep. There has never been 100 block reorg on the Bitcoin chain. So that's the, yeah. So the question is, what happens if you wait 6 blocks, right? Coinbase only wait 2 blocks. So if it's good for Coinbase, it's good for me. All right, thank you very much.